Given g of x is equal to negative 5x squared minus 5x minus 5, we want to find the domain. So here, when we want to find the domain of a function, we need to check for two cases. The first one is the fraction. If we have a fraction, we need to set the denominator not equal to 0 and solve. The second case is the square root or the even root, the square root, the fourth root, the sixth root, or the even root. So inside the square root, set it greater than or equal to 0 and solve. So if we look at our function g of x here, we don't have fraction, we don't have square root. This is just a polynomial. So here, the domain is from negative infinity to infinity, or real number. Given c of x is equal to x minus 5 over 7 minus x, we want to find the domain. Again, check for two cases. The first one is a fraction. The second one is the square root. Here we have fraction. So the denominator cannot equal to 0 and solve. So 7 minus x cannot equal to 0. We can add the x over. So here we have 7 cannot equal to x. So on our number line we have 7. X cannot equal to 7, so there's an open circle here. That means our answer is everywhere else. So on the left side and on the right side. So the domain here, it goes from negative infinity to 7, not including the 7, so we have parentheses, union from 7 to infinity. Given h of x is equal to 2x over x squared plus 7x plus 6, we want to find the domain. So with this one, again, we have fraction, so the denominator not equal to 0. So we have x squared plus 7x plus 6 cannot equal to 0. Here we have three terms, x squared, x no x. The number in front of x squared is 1. So we need two numbers that multiply give us 6, add give us 7. So here we have 6 and 1. So we have x plus 6 times x plus 1 cannot equal to 0. Set each group not equal to 0 and solve. So x plus 6 cannot equal to 0, and x plus 1 cannot equal to 0. Solve x, so minus the 6 over, and we have x cannot equal to negative 6. The other one minus 1 over, so x cannot equal to negative 1. So on our number line, we have two numbers. Make sure the smaller number is on the left side, the larger number is on the right side. And we cannot have negative 6. We cannot have negative 1. So there is an open circle at negative 6 and at negative 1. So our answer is everywhere else. So on the left side, in the middle, and on the right side. So our domain, we have from negative infinity to negative 6, not including negative 6. So we have parentheses, union from negative 6 to negative 1, parentheses, union from negative 1 to infinity. Given f of x is equal to the square root of 6x minus 18 plus 6, So here we don't have fraction, but we do have square root. So inside the square root, 6x minus 18 needs to be greater than or equal to 0. Solve the inequality. Add 18 over. And we have 6x is greater than or equal to 18. Divide out the 6. So x is greater than or equal to 3. So here on our number line, we have 3. X needs to be greater than, so the arrow is heading toward the right. It's greater than or equal to, so there is an equal sign. So this is a bracket. So our domain here, we have bracket 3 to infinity, open parenthesis. Given f of x is equal to the square root of x plus 10 over 13, find the domain. So here we have fraction, so the denominator cannot equal to 0, and 13 is not equal to 0, so this is true. We also have the square root, so inside the square root, x plus 10 needs to be greater than or equal to 0. So solve minus the 10 over, and we have x is greater than or equal to negative 10. So here there's only one condition. X needs to be greater than or equal to negative 10. So we have negative 10. X needs to be greater than, so the arrow is heading toward the right. There's an equal sign, so this is a bracket. So here the domain is bracket negative 10 to infinity, parenthesis.